Welcome back. We'll be discussing about gliding flight. Okay? You know we have Sinus 1, 2, 3, the glider. Sinus 1, 2, 3, glider with us. In fact, this is a motor glider. Conventionally, gliders didn't have any engine, right? They were launched by cables, and there was a winch, and the winch will wind the cable, and the glider will attain height. At a particular height, the pilot will release the cable, and then he will be doing the gliding flight. That is, in the gliding flight, there is absolutely no thrust, no engine installed. But nowadays, there is a new concept has come where we talk about motor glider. That is, we install small engine on the glider, and instead of launching through a cable, we use that engine to take it to a height and then switch off the engine. And if required, there are provisions where the engine can be folded inside the fuselage also, so that now you can fly like a glider, and when you lose the height and you want to go for further height now, then you take out the engine, switch on the engine, again go to a height, and take the engine back into the fuselage and start gliding. Right? That way the endurance of the glider has been increased. Okay? The problem with winch launch or cable launch was that once you reach a height, you will be constantly losing the altitude unless you get some thermal, right? Which all the time you may not get. Right? So we will be talking about glider via gliding flight. Please remember, when I am talking about gliding flight, I am telling there is no engine, there is no thrust. Ideally speaking, when an aircraft will come for a landing, we also try to set the thrust to the lowest minimum. And that means if you are designing an aircraft, it needs to have some benchmark gliding capability, which is essential for approach and landing. Okay? So gliding flight doesn't necessarily mean I am flying with a glider. So gliding flight is one of those flight maneuvers which a normal aircraft needs to do, or the designer must ensure that he has enough capability to do requisite gliding flight. Okay? So now let us see how do we explain a gliding flight. Look at this diagram. This is the aircraft, or to be more specific now we will call it a glider, which is descending. This is the velocity vector. This angle gamma is called the flight path angle. And if we recall, we defined three angles. If this is the velocity vector, and this is the chord line or reference line, and this is the horizontal, then this angle is gamma, which is called flight path angle. This angle, that is chord line and velocity vector in the vertical plane, is called angle of attack. And this angle from chord line to horizontal, notation is theta, it is called pitch angle. Right? Climb angle, you understand, the velocity vector tells how it is going and gaining the altitude. Pitch angle tells what is the attitude of the airplane, and angle of attack tells you the angle between the chord line and the velocity vector, because that angle of attack is responsible for giving the lift forces, and as a side effect you also get drag. Correct? But if I try to see this diagram, I ask a question, what is the angle of attack here? This velocity vector is aligned to the chord line. This is a simplified diagram. There is the assumption that we are flying at a very low angle of attack. So actually there is an angle of attack, but since we are assuming alpha small, we are drawing it like this. Once we agree and understand this drawing with a clarity that this gamma is the flight path angle and which is negative. This is the convention of gamma positive, that is when you are climbing, the flight path angle is positive. When I am descending, the flight path angle is negative. Okay? If this diagram is clear, now let us see. Let me write this. I am assuming that I am coming such that forces are balanced. Okay? So this is the lift, and the W cos gamma is this component of weight, which is balanced by lift, and drag. There is a W cos gamma, W sin gamma here, so they are balanced. So if I write this equation, I could easily show that tan gamma is equal to 1 by L by D or 1 by CL by CD. Correct? What is gamma? Gamma was this angle, flight path angle. Now think of, if I want to have a maximum range, that is I want to go to a larger distance, then what should be the gamma? For range max, I should ensure that gamma should be as low as possible. Right? I go like this. Okay? For the range. That means gamma minimum means from here, gamma will be minimum if, that is gamma minimum if CL by CD is maximum from this relationship. And this condition is not unknown to us, we are very familiar. CL by CD max means what? It means I should fly such that CL equal to CD naught by K. And where from I get CD naught and K? Remember, drag polar, every airplane is benchmarked with the drag polar, that is CD equal to CD naught plus K CL square, where K is nothing but 1 by pi aspect ratio E. So once you buy an airplane, the manufacturer will give you the drag polar. That drag polar will be evaluated through experiments, through flight tests, through analytical method, all corroborated together and finally validated through flight test, and then that is a benchmark drag polar for an airplane. Okay. So we have seen if this is the glider here coming down like this, for maximum range or to be maximum from here, this gamma should be minimum, be as low as possible. But the next question comes to my mind, if I decide to stay for long in the air, that is, I want to have larger time airborne, that is, I want to stay for longer duration, that explicitly gives me a message that is possible if rate of descent is minimum. You are familiar with rate of climb. Now I am talking about rate of descent. If this is minimum, then I can stay for longer hours. So let us find out what is that condition for a gliding flight. Why I am saying gliding flight? Please understand, gliding flight means there is no thrust. Gliding flight doesn't mean it is only referred to gliders. Even an airplane should have a gliding flight characteristics, right? So if I am talking about larger time or endurance max for a gliding flight, how do I model it? How do I try to understand? Okay. You know, lift equal to half rho v square S CL, that is equal to W cos gamma. We have seen from here, lift equal to W cos gamma. This angle is also gamma, right? And that clearly gives me an expression V equal to 2 cos gamma by rho CL into W by S. What is W by S? W by S was what? Very important parameter. It is called wing loading. That is, if W by S is low, that means for a given weight, it has larger wing area. Larger wing area means it is very lift effective. Lift depends upon the area. So I could see that if I want this V to be low, then W by S should also be low. Also it tells me that as I go higher and higher, as I gain altitude, this V required to balance lift equal to weight, in a sense lift equal to W cos gamma, that also increases. That means because rho goes on decreasing as I go higher and higher, so naturally V also goes on increasing. Right? So minimum velocity you get at sea level for a given CL and wing loading. Right? We are talking about rate of descent, rate of descent, or this is called sink rate. Better word is sink rate. Okay. Let me erase this. Textbook you will see that rate of descent or sink rate, climb rate or sink rate. What is that rate of descent? Is nothing but V sine gamma. From the diagram you could see that. This is V, this is gamma. So this velocity component is V sine gamma, and that is the rate of descent or sink rate. Okay. So if V is this and V sine gamma is rate of descent, so I can write rate of descent equal to V is 2 cos gamma by rho CL W by S. This is V. And what is sine gamma? Remember, we have seen tan gamma is equal to 1 by CL by CD. For small climb angle or small angle of descent, right? If gamma is small, then I can write tan gamma is approximately equal to sine gamma. No objection, right? So now what I will do, rate of descent was V sine gamma. V is this expression. For sine gamma, I will take this expression of tan gamma, which is 1 by CL by CD. So 1 CL by CD. So what are you seeing here? See the rate of descent expression very carefully. If I see now this rate of descent, I could easily see that it is proportional to CL 3 by 2 by CD. Right? This CL is here, CL half is here, so CL 3 by 2 and CD goes in the numerator. Okay? CL 3 by 2 by CD. So if I want rate of descent or sink rate to be minimum, what does it mean? It means other things remaining constant, CL 3 by 2 by CD should be maximum. You are also familiar with this condition. What this condition gave us? It simply means that I should fly at a CL which is equal to 3 CD naught by K. Clear? So what we have learned now? One thing, if I want range maximum, then I must fly CL equal to CD naught by K, because I am trying to fly such that CL by CD is maximum. And for endurance maximum, I must fly as CL equal to 3 CD naught by K, because I am flying at a condition CL 3 by 2 by CD maximum. Okay? No issues? Everything is clear? Okay. Now, let us go closer to a pilot. Okay. We are requesting pilot, please glide at a constant speed. It doesn't have a thrust. So it's very serious expectation you are having from a glider pilot. It's very easy on the blackboard, you say it is coming, forces balance. But here, what are the controls he has got to balance the forces? Nothing, except elevator will try to manage altitude or try to see CL and V, how he can manage that. Again, we are telling you fly such that CL equal to CD naught by K to get range maximum. Let us see what is the implication of this on the pilot. Okay. Let us take a typical example. Let's say we are talking about a glider. Take a case of a glider. The aspect ratio is around 20. Let's say E is 1 for simplicity. And let's say CD naught for the glider is 0.020. So if I write the drag polar, it is 0.020 plus 1 by pi. Aspect ratio is 20 into E CL square, and this value is roughly 0.020 plus 1 by roughly 60 CL square. This is a very rough value. See, 1 by 3.1416 into 20, so 1 by 60. So what is the value of K? K is 1 by 60 because approximately like this, okay? Because CD naught plus K CL square. Now what we have suggested the pilot from our analysis, if you want to go for range maximum, sir, please fly such that CL equal to CD naught by K. That means for this glider, CL equal to CD naught is how much? 0.020. How much is K? 1 by 60. So what is this value? This value is around 1.2, and typically this value will be around 1.1. This is an approximate number just to give you a feel. Is this clear? CD naught by K, K is 1 by 60, so 60 goes up, so this becomes 1.2, and this is around 1.1. So what are you telling? You are telling pilot, sir, we want range maximum, please fly at CL 1.1. Now what is happening, you see? The moment you say this, what is actually the real situation? You know by now that if I plot CL versus alpha for an airplane, maximum value is around 1.2. If I don't use or flaps and etc. normal, it is 1.2, the realistic value, okay? And this angle is called alpha stall, which is also between 11 to 13 degrees, around that number. So essentially what you are telling, dear sir, to get maximum range, you fly somewhere here. Are you expecting something really responsible by giving this statement? Answer is definitely no, because although your CL is coming 1.1, which tells you that your range will be maximum for a glider, but if you try to fly the glider near the stall, slight upward gust will take it to stall and lot of disturbance will come to the airplane. When I say the airplane has gone into stall, please understand that doesn't mean that we cannot come out of the stall, right? Okay, but we avoid going to a stall situation. So all these numbers, whatever you generate as a designer, my request is, after these numbers are generated, please think from pilot's point of view, that whether you have given enough bandwidth in your design so that pilot can fly the machine safely and with good predictability, right? He should not go into region of uncertainty every time, okay? And that is what I will be stressing again and again, that any number you put on the blackboard, any number you put on a design board for an airplane design, please talk to your pilot in command, take his input, and then finalize the whole configuration. Then only we can understand what truly airplane performance means. Thank you.